Imagine waking up, hopping into your car, and instead of being stuck in traffic, you simply take off, gliding above the gridlock below. Sounds like something straight out of a futuristic movie, right? Well, what if I told you that a company has actually made this a reality? And not just any company, Honda. But here's the twist. Elon Musk, the CEO of Tesla, has warned that this new flying car might disrupt the entire electric vehicle, EV industry. Musk's concerns? Flying cars could bring significant noise pollution due to the immense wind forces they generate. So what exactly is Honda working on that has even the man behind Tesla so worried? And could this actually be the beginning of the end for electric vehicles, as Musk suggests? Should we take his warning seriously? Elon Musk is no stranger to making bold, attention-grabbing statements. As the CEO of both Tesla and SpaceX, he's built a reputation for forecasting game-changing innovations, often stirring up debates and discussions around the globe. But what makes Musk's predictions so influential, and how accurate have they been over time? Musk's history with predictions is a mix of hit and miss. Back in 2016, he confidently declared that Tesla would achieve full self-driving capability by 2017, with cars capable of driving themselves while passengers relaxed or even slept. Yet here we are in 2025, and that level of autonomy still hasn't been realized. Tesla's full self-driving feature still requires active human supervision and isn't fully autonomous. In 2019, Musk promised that by 2020, there would be over 1 million Tesla robotaxis driving autonomously on the road. That target has come and gone, and the fleet of robotaxis hasn't materialized. But despite these ambitious timelines not always panning out, Musk has also had major successes. Tesla has completely transformed the EV market, making electric vehicles not only practical, but also highly desirable. His work with SpaceX, particularly in developing reusable rockets, has revolutionized space travel, drastically reducing costs and making history in aerospace technology. So, with all of this in mind, how should we interpret Musk's latest prediction about Honda's flying car potentially challenging the future of electric vehicles? On one hand, Musk has been right about many things, but on the other, his ambitious timelines don't always come to pass. His skepticism about flying cars isn't new. He's previously raised concerns about the noise pollution they might cause, which could make them impractical for widespread use. Does this mean we should believe Musk and expect flying cars to really impact the EV industry? Or is it just another prediction that may take longer to realize than Musk envisions? With his track record of both bold claims and groundbreaking innovations, only time will tell if Honda's flying car could truly disrupt the world of electric vehicles, as Musk has warned. Elon Musk has raised concerns about the potential noise and safety risks of flying cars, comparing their noise levels to that of a hurricane. He also warned that if parts were to fail, they could fall from the sky, posing serious dangers. So if Musk sees this flying car as a game changer, it's important to understand why Tesla's incredible achievements over the past decade are so relevant in this conversation. One company that's been at the forefront of bringing electric vehicles into the mainstream is Tesla. Once seen as a bold startup with big dreams, Tesla has surpassed expectations and become the face of the electric vehicle revolution. Today, electric cars are no longer just for environmental advocates or tech enthusiasts. They represent the future of transportation. But how did we get here? More importantly, is Tesla's dominance in the EV market unshakable, or is it now facing its toughest challenge yet? The rise of electric vehicles has become a global phenomenon. Just a few years ago, EVs made up a small percentage of car sales, hindered by high costs, limited range, and insufficient charging infrastructure. Fast forward to today, and the situation has completely changed. In 2023 alone, global EV sales soared past 14 million, making up nearly 18% of all new car sales, an incredible jump from just 4% in 2020. Governments worldwide are implementing ambitious climate policies, consumers are increasingly opting for cleaner alternatives, and battery technology is advancing at an astonishing rate. Tesla deserves a significant portion of the credit for this dramatic shift. Founded in 2003, the company's mission was simple yet revolutionary: to accelerate the world's transition to sustainable energy. When Tesla introduced the Roadster in 2008, it proved that electric cars could be sleek, powerful, and thrilling. But that was just the beginning. The real breakthrough came in 2012 with the launch of the Model S, a vehicle that redefined expectations for electric vehicles. With long-range capabilities, blistering acceleration, and cutting-edge technology, the Model S was the first electric car that could truly compete with traditional luxury vehicles. But Tesla wasn't finished. The true disruption arrived in 2017 with the release of the Model 3, an affordable electric car aimed at the mass market. The response was overwhelming. Within the first week alone, over 325,000 reservations were made. The demand was so high that Tesla faced significant challenges in meeting production targets. Despite facing production delays and month-long wait times, the Model 3 ultimately lived up to its promise, becoming one of the best-selling electric vehicles in history. This solidified Tesla's position as a leader in the electric revolution. But it wasn't just about the cars themselves. Tesla's success is also due to a combination of cutting-edge technology, aggressive growth strategies, and smart business decisions. One of Tesla's key advantages is its battery technology. The company recognized early on that for EVs to become widely adopted, batteries needed to be both affordable and efficient. Tesla's gigafactories, massive facilities dedicated to producing lithium-ion batteries at scale, have helped drive down costs while enhancing performance. As a result, Tesla vehicles now have some of the longest ranges in the industry, easing the range anxiety that once plagued electric cars. Charging infrastructure is another area where Tesla has dominated. While most automakers depend on third-party charging networks, Tesla built its own, the Supercharger network. This vast network of high-speed chargers is strategically placed along major highways and in urban centers, making long-distance travel in an EV not just feasible, but convenient. By 2024, Tesla had over 30,000 supercharger stations worldwide, offering unmatched accessibility for its drivers. Tesla has also leveraged software as a major advantage. Unlike traditional automakers who treat their cars as finished products at the point of sale, Tesla continuously improves its vehicles with over-the-air software updates. Features like autopilot, Tesla's semi-autonomous driving system, have evolved over time thanks to these updates. While full self-driving capability is still in development, Tesla's AI-driven approach to vehicle automation is pushing the limits of what's possible. Another key factor in Tesla's success is its direct-to-consumer sales model. Instead of using traditional dealerships, Tesla sells directly to customers, cutting out the middleman and maintaining full control over pricing and the customer experience. This approach has helped Tesla scale quickly and build strong brand loyalty, something few automakers can match. However, despite all its strengths, Tesla's reign is far from guaranteed to last forever. In recent years, the electric vehicle (EV) market has become more competitive, with both legacy automakers and new startups eager to grab their share. Companies that once viewed electric cars as a passing trend are now investing billions into their development. One of the most interesting challengers in the space is Honda. While Honda might not be the first name that comes to mind when thinking about EVs, the company is a powerhouse in the automotive industry with a history of innovation, ranging from motorcycles to fuel-efficient cars. Honda has shown time and again that it can adapt to changing times. Before Tesla made EVs mainstream, Honda dominated the hybrid market with models like the Honda Insight and the well-known Honda Civic Hybrid, paving the way for fuel-efficient transportation. Now Honda is making bold moves in the electric vehicle space. The company has revealed plans to transition away from traditional gasoline engines, pouring significant resources into battery technology, hydrogen fuel cells, and even electrified aviation. The Honda Prologue, the company's first mass-market EV, is set to hit the road soon, signaling the start of a new era for the Japanese automaker. But Honda's ambitions go beyond just ground transportation. So, what exactly is Honda working on? Could it truly disrupt the EV industry? To answer that, we need to dive into Honda's history of innovation and explore its future plans. Honda, the quiet giant in the automotive world, was founded in 1946 in post-World War II Japan by Soichiro Honda and Takeo Fujisawa. The company began as the Honda Technical Research Institute, focusing on motorized bicycles. By 1949, they introduced the Dream D-Type, their first mass-produced motorcycle, which set the foundation for future successes. By 1959, Honda had become Japan's largest motorcycle manufacturer and had expanded into the American market. The 1960s marked Honda's entry into the automobile industry, beginning with the T360, a small key-class truck, followed by the S500 sports car. These early models demonstrated Honda's commitment to reliability and engineering precision. But it was the launch of the Honda Civic that truly marked a turning point in the company's automotive journey. In 1972, Honda introduced the Civic, a model that truly revolutionized the compact car industry. Created during a time of fuel crises, the Civic stood out for its exceptional fuel efficiency and affordability, quickly becoming a global bestseller. But Honda's innovation didn't stop there. In 1975, the company introduced the CVCC engine, the first to meet U.S. clean air standards without requiring a catalytic converter. This groundbreaking achievement highlighted Honda's commitment to both environmental responsibility and technological progress. Before electric vehicles became the main focus of sustainable transportation, hybrids played a key role in bridging the gap between traditional combustion engines and full electrification. Honda was at the forefront of this movement. In 1999, the company launched the Insight, North America's first mass-produced hybrid vehicle, which boasted an impressive EPA rating of 61 miles per gallon in the city and 70 miles per gallon on the highway. The Insight set new standards for fuel efficiency. Building on this success, Honda introduced hybrid versions of popular models, including the Civic Hybrid in 2003, providing an eco-friendly option without sacrificing performance. The Accord Hybrid followed in 2005, further solidifying Honda's reputation in the hybrid market. Honda's commitment to hybrid technology wasn't just about keeping up with market demand. It was about leading the industry toward a more sustainable future. Their integrated motor assist IMA system, first introduced with the Insight, combined electric and gasoline power to deliver optimal efficiency. As the global automotive landscape continues to shift toward electrification, Honda is once again positioning itself at the forefront of innovation. In 2024, the company launched the Prologue, an all-electric SUV developed in partnership with General Motors. Sharing components with the Chevrolet Blazer EV, the Prologue offers a range of up to 296 miles, meeting the growing demand for long-range electric vehicles. But Honda's vision goes beyond just battery electric vehicles. The company has been a pioneer in hydrogen fuel cell technology for over 2 decades, and in 2024, they began production of their next-generation hydrogen-powered vehicle. In 2025, Honda will debut the CR-V FCEV at their Performance Manufacturing Center in Ohio. This model features a US-made fuel cell system paired with plug-in EV charging capability, offering both short-range electric driving and the flexibility of fast hydrogen refueling for longer trips. Understanding the crucial role infrastructure plays in the adoption of hydrogen vehicles, Honda has also invested heavily in developing fuel cell systems for various applications, including commercial vehicles and stationary power stations. Their collaboration with General Motors in Fuel Cell System Manufacturing LLC further demonstrates their commitment to advancing this technology. In addition to their efforts with EVs and hydrogen, Honda is ramping up its focus on hybrid technology. By 2030, the company plans to double global hybrid sales to 1.3 million units annually. This strategy reflects current market realities, where hybrids serve as a practical step toward full electrification. Starting in 2026, Honda plans to roll out more fuel-efficient hybrid systems for compact and mid-size models, improving engine platforms and control technologies. From motorcycles to fuel-efficient cars, hybrids, and now a strong push into electric and hydrogen-powered vehicles, Honda has consistently shown its ability to evolve with the times. They are also exploring ventures that go beyond traditional automotive manufacturing, such as flying car technology. Honda's innovative moves could reshape the future of transportation. The concept of flying cars has long captured the imagination of generations, symbolizing a future where we navigate the skies just as easily as we drive on roads. From science fiction to ambitious engineering prototypes, humanity's quest to combine automotive convenience with aerial freedom has been relentless. But as we stand on the edge of this long-anticipated future, we must ask, are we truly on the brink of the flying car era, or is it still a distant dream? The journey toward flying cars is filled with innovation, ambition, and often unforeseen challenges. In 1917, aviation pioneer Glenn Curtiss introduced the Curtiss autoplane, a triplane designed to transition smoothly between driving and flying. Despite its groundbreaking design, the autoplane never fully realized its potential. The Curtiss autoplane never achieved sustained flight, and with World War I redirecting priorities, experimental endeavors like these were set aside. Fast forward to 1947, when the Convair Model 118 emerged as a symbol of hope for personal aerial vehicles. This prototype featured a detachable aircraft component mounted atop a car chassis, allowing drivers to transition from the road to the sky. However, during a test flight, a critical mistake occurred. The pilot, misreading the fuel gauge, took off with insufficient fuel, leading to a crash. Fortunately, the pilot survived, but the project was ultimately doomed. In the 1970s, the Aerocar project aimed to combine the Ford Pinto with a Cessna Skymaster, an ambitious attempt to create a hybrid vehicle that could function as both a car and a plane. Unfortunately, a structural failure during a test flight led to a fatal crash, highlighting the significant challenges of blending automotive and aeronautical technologies. Today, the dream of personal aerial vehicles is experiencing a revival, thanks to technological advancements and a renewed focus on sustainable urban mobility. Several companies are leading the charge. For instance, Joby Aviation, based in California, is developing an electric vertical takeoff and landing eVTOL aircraft designed to function as an air taxi. With a range of up to 100 miles and speeds of 200 miles per hour, Joby's aircraft aims to revolutionize urban transportation. Significant investments, including substantial backing from Toyota, have supported Joby in its quest for commercial certification and operational readiness. Hyundai is also getting involved with the introduction of its Supernal SA2, unveiled at the 2024 Consumer Electronics Show. The Supernal SA2 features 8 tilting rotors and a V-tail design, allowing it to cruise at 120 miles per hour for journeys up to 40 miles. Emphasizing noise reduction, the SA2 is designed to be as quiet as a household dishwasher, addressing one of the major concerns around urban air mobility. In a fusion of automotive luxury and aerospace expertise, Porsche and Boeing have partnered to develop a sleek 2-passenger eVTOL. This concept features a carbon fiber fuselage, bendable wings, and tilt-action ducted fans. The aircraft is designed to offer both autonomous and pilot-operated flight modes. While still in the conceptual phase, this collaboration highlights the growing interest of traditional automakers in aerial mobility solutions. Automotive giant Stellantis has invested $150 million in Archer Aviation to produce the Midnight, an all-electric eVTOL, electric vertical takeoff and landing, vehicle designed for urban commutes. With a range of around 100 miles, the Midnight focuses on short-distance travel, aiming to ease urban congestion and reduce travel times. Production is set to begin soon, with plans to ramp up manufacturing in the coming years. Meanwhile, Suzuki is also making strides in the flying car sector with its SkyDrive. This all-electric flying car is equipped with 12 motorized rotor units and can carry 2 passengers and a pilot. With a range of 25 miles and a top speed of 62 miles per hour, the SkyDrive is set to make its debut in Osaka, showcasing Suzuki's commitment to advancing urban air mobility. Honda, renowned for its innovations in automotive and motorcycle industries, is applying its extensive engineering expertise to the development of flying cars. Building on the success of the Honda Jet, a light business jet known for its efficiency and performance, Honda is working on a hybrid electric aircraft. This vehicle combines electric propulsion with gas turbine engines, offering a range of approximately 250 miles. Honda's goal is to overcome the range limitations of purely electric aircraft, making inner-city air travel a realistic option. In addition to their EV ventures, Honda has filed multiple patents related to flying vehicle technologies, signaling a strategic focus on aerial mobility solutions. It appears that Honda may be on the brink of cracking the code for an affordable flying car. But how could flying cars pose a threat to the EV industry, which is gaining so much praise? To understand this, imagine a future where your daily commute involves soaring above traffic rather than sitting in it. This once fantastical idea is now becoming more tangible with the rise of flying cars. As these vehicles move closer to reality, an important question emerges. Could the growth of flying cars present a serious challenge to the electric vehicle industry? Urban congestion is a persistent issue in cities worldwide. Traditional vehicles, including EVs, are still restricted by the limitations of road networks, which leads to traffic jams and longer travel times. Traffic jams and long commute times are major problems, but flying cars or electric vertical takeoff and landing eVTOL vehicles offer a game-changing solution. By utilizing the vertical space above us, these vehicles can avoid road obstacles and take direct aerial routes between destinations, significantly cutting down travel times. For example, a trip that might take an hour by car through busy streets could be completed in a fraction of the time using an aerial route. This not only eases the burden on current road infrastructure, but also provides an exciting alternative to traditional commuting. And there's more to consider. While electric vehicles, EVs, have made impressive strides in extending their range, long-distance travel is still challenging due to the need for frequent charging stops and longer travel times. Flying cars could transform long-distance travel by offering faster, more direct routes. Unlike EVs, which are limited by road networks, flying cars can cover considerable distances in a much shorter amount of time. For instance, Aleph Aeronautics has revealed a flying car prototype with a flight range of 110 miles and a driving range of 200 miles. This dual capability allows for flexibility in both urban and inner-city travel, potentially reducing the reliance on ground-based EVs for longer journeys. As the demand for aerial mobility grows, infrastructure development is already underway in cities to support flying cars. For example, Port San Antonio is constructing a vertiport, a hub for air taxis that will help streamline aerial transport across the region. While the rise of EVs has led to the development of expansive charging networks, the infrastructure needs for flying cars are different and more complex. eVTOLs require specialized takeoff and landing sites called vertiports. These facilities must be carefully placed to ensure easy accessibility while minimizing noise and disruption to local communities. The design of vertiports is critical, with options ranging from rooftop and ground-level sites to even floating platforms in urban waterways. Moreover, the energy demands of flying cars are substantial, requiring powerful systems capable of rapid charging. This presents another challenge in creating the necessary infrastructure to support this emerging technology. Especially in urban areas, the challenges are significant, where the electrical grid is already under pressure. Upgrading the existing infrastructure to accommodate the increased power demand for flying cars will require a lot of investment and careful planning. Air traffic management is another major obstacle. Integrating this new class of low-altitude aircraft into busy airspaces requires advanced traffic control systems to prevent accidents and ensure smooth, efficient routing. Developing these systems will need technological advancements as well as new regulations to govern urban air mobility as the future of personal transportation unfolds. Traditional automakers aren't staying on the sidelines. Honda, with its long history of innovation, is stepping into the world of flying vehicles. Building on its success with the Honda Jet, the company is looking into developing electric vertical takeoff and landing eVTOL vehicles that could change personal mobility. This marks a potential shift in Honda's strategy, adding aerial transportation solutions to its offerings. Now the big question, what exactly is Honda bringing to the table? Could it be the revolution we've all been waiting for? Elon Musk, Tesla's chairman, has never been afraid to make bold claims, but his recent one sent shockwaves through the industry. Musk stated that Honda's new flying car, priced at just $4,999, could potentially destroy the entire electric vehicle market. Coming from the man who transformed the EV industry, this bold statement certainly warrants closer scrutiny. Could it be true? The answer could lie in the Honda Aspire, a vehicle that might completely change the way we think about personal transportation. While other companies have talked about flying cars for years, Honda has been quietly developing technology that could make them a reality. Unlike previous prototypes that were expensive novelties, the Aspire is expected to be priced at an astonishingly low $5,000, a fraction of what most EVs cost today. If it lives up to its promise, it could make traditional electric vehicles obsolete. Honda's success with the Honda Jet program is a testament to their ability to build safe, efficient, and reliable flying machines. The Aspire is said to leverage this expertise by combining Honda's hybrid electric propulsion systems with vertical takeoff and landing capabilities, marking a significant step forward in aerial mobility. It doesn't require a runway, it doesn't consume excessive fuel like helicopters, and unlike EVs, it's not limited by roads, traffic, or charging stations. In every sense, it's the ultimate commuting machine. Sources close to Tesla's CEO have revealed that Elon Musk recently paid a discreet visit to Honda's R&D facilities in Japan. Reports suggest that Elon was especially intrigued by the Aspire's hybrid propulsion system. While Tesla has stuck to an all-electric model, Honda is reportedly taking a different approach, one that overcomes the battery range limitations while still prioritizing environmental efficiency. Elon has previously dismissed flying cars, citing concerns about noise and safety. However, if he took the time to see the Aspire up close, it suggests he truly believes Honda has cracked the code. If the Aspire delivers on its promises, it could disrupt the electric vehicle market in ways we've never imagined. One of the biggest challenges electric vehicles face today is infrastructure. The need for charging stations, power grids, and sustainable battery supply chains, all requiring massive investments to scale. Flying cars, however, need something entirely different: vertiports, airspace regulations, and a whole new transportation ecosystem. This shift could redirect funding and innovation away from traditional EVs, potentially ushering in a new era of personal flight. But here's the kicker. According to Elon, Honda may have something even bigger in the works. While the Aspire is making waves, there are whispers in the industry suggesting this is just the beginning. Honda's history of methodical, well-engineered innovation hints at something beyond a single flying car. Could they be planning a network of autonomous air taxis, or even a full-scale aerial mobility system? If Elon Musk is taking them seriously, then the rest of the industry should too. So do you think the future is closer than we thought? Let us know in the comments.